Hello and welcome to this video on data distributions, and we are going to talk about data sets with regards to the shape and skew of data. Our objective today is students will be able to describe the shape of a graph. For your prior knowledge, I would like you to go ahead and calculate the mean and the median of these two data sets. So you don't have to copy down these data sets, but in your prior knowledge, go ahead and calculate the mean and the median. I'll pause the video and I will let you go ahead and do this right now. Okay, so hopefully you have paused the video and came up with the mean and median for these data sets. If you went ahead and added up these numbers here and then divided by the 9 that there are, you should have gotten a mean of 104. 104. The median of this data set, well, I have 9 numbers, so if you want, you can do the crossing game that we have talked about. 1, 2, 3, 1, 2, 3, 1, 1, and we also have 104 as our median. So notice this is perfectly balanced in terms of mean and median. And here I have the same numbers, but I have a 33 added. So if I take 936, which is the total over here, and I added 33, we get 969, and we're going to divide that value by 10, which now gives us a mean of 96.9. So notice that mean dropped a lot just because of this 33. And now if I want to calculate the median, this 33, right, we can say goes up here, and I'm going to cross that out. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So my middle two numbers, I'm going to split the data set. It'll have 5 and 5. There's 4. So 5, and then here's the 6. These are my two middle numbers, and notice my median should be smack dab in between 104. So what value exists between 104, or what's the average of those two? That is 104. So hopefully you guys got those. And I kind of am hoping we set this up so that you see really just adding one number in that value specifically, or a value like that, how it can affect the mean, but notice the median didn't really change. And today we are talking about shape of a graph and shape of data sets. So another measure that helps us describe and compare sets is the shape of the data. So how does data look? And here you'll see a dot plot ranging from 101 to 109, and we want to calculate the median. So the median, if I went ahead and calculated it, it would be 105. It would be right here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data points. So if I cut 15 in half, that's going to be 7 on each side, and the 8th number would be our data. 1, 2, 3, 4, 5, 6, 7. So indeed, in fact, right here is our median. What is the mean? So if I was to add up all of these values and then divide by 15, I would get 105. So notice here the mean and the median are in the exact same spot, and that was the case with our prior knowledge example number 1. So when I have a data set that is like this, notice there each side is mirror images. We call this a symmetric distribution. Symmetric. Can you say symmetric? Symmetric means that one side is exactly like the other, right? If I folded this side over onto the other side, that is symmetric. And what a symmetric distribution is, it has a mean equal to the median. It's described as perfectly symmetrical, and the mean is exactly on the peak. And kind of another idea we're going to talk about is skew. And no, I'm not talking about like a skewer, like food. I'm talking about skew in terms of math. The data is not being pulled. It's perfectly symmetrical, right? The one side matches the other side. Please make sure you have these in your notes. And the other idea I want to talk about is that the line of symmetry, where my data is can be folded over onto the other side, is smack down the middle, right? And that's kind of idea we've talked about before. A line of symmetry is here. So now I want to move on to another situation, and we have a table here talking about basketball games, and this is a player, Adriana, who has scored in her first 5 games, and these are the numbers she's put up. She put up 3 points, 1 point, 5 point, 3 points, and 3 points, and here's her data on a dot plot, and notice that her data is symmetric. It's symmetrically distributed. But imagine if Adriana all of a sudden had a breakout game, right? The scouts had been like, Adriana's not that good, you know, we're not going to cover that much. So instead of putting up 5 points in game 5, what if she puts up 30? So now her data looks like this, and notice that this 1 point way out here pulls the data way out here, and we'll talk about this being an outlier towards the end of the unit and what outliers are specifically, but that data value pulls it way out there. So now I have a huge long tail shooting this way. Okay, so since she scored this 30-point game, right? Now her data is being pulled that way. The tail is being pulled far to the right. Well, if we had a data set going back to kind of our original example, and we were to put it in order from least to greatest, and we calculated the median, we would have a median of 102 for this data set. And if I did the same, if I calculated the mean, if I added all these values up, and I divided by all of the dots, I would get 102.47. And now notice my mean and my median are kind of similar, but notice that the mean is greater than the median. It's on the right side. The mean is greater than the median. It's on the right-hand side. So what we call this is we call this a skewed right distribution. And the reason is because my tail gets pulled to the right. That's the easy way to think of it. The other way of thinking it is that my mean, my average, is greater than my middle. If the mean is bigger than the middle, if it's on the right side of the middle, and we can think about right and left in terms of a number line, correct? My mean is on the right side of my middle, then it is skewed right. The tail is being pulled to the right. Okay, so for our notes, make sure you get these in. Here I have a mean value that is greater than the median. The tail is longer on the right side. The mean will be on the right side of the peak, and we call this a positive skew. A positive skew. Make sure you get these in your notes. And the last idea I want to talk about is I want to talk about, I guess, well, we'll get there. I want to talk about Kobe Bryant. So I'm a Lakers fan. I don't show it much these days. The Lakers aren't doing too hot, and everyone's all about Golden State. But I'm a Lakers fan, guys. I admit it. Okay, and my boy Kobe, Black Mamba, he doesn't play anymore. But here's some points that Kobe put up. I mean, these are average. These are average points for Kobe. Okay, in 5 games. So here we go. Here's Kobe's points. And it's symmetric, right? I created a dot plot. It's symmetric. But now imagine all of a sudden, instead of in game 4 he scored 20, instead of 26 points, he scores 2. Man, he only played a couple minutes, got injured or something, hurt a finger. Now I have this data distribution, and now notice that my tail is being pulled far, far to the left. It's being pulled far to the left. So again, going back to this, I have a median here of 109. A mean, if I calculate and average these, would be 108. Now I have a mean that is on the left side of my middle, of my median. Well, when my average is on the left side of my middle, we call this skewed left. So just like in the Kobe Bryant situation where he had a game that all of a sudden he had a data point way down here, it pulls his numbers and his data all the way this way to the left. It skews it to the left. Okay, and a thing to remember is that the mean is less than the median on the number line. It's on less than. It's on the left side. So notes for skewed left. The mean is less than the median. We have a longer left tail. The mean will be on the left side of the peak, and we call this negative skew. Negative skew. Okay, so it's very easy to identify with the long left tail. So let's go ahead and look at some examples. Can you identify these? Here I have a data distribution, and if it helps you, you can kind of draw nets over these guys. So here's my data. And notice here I have a tail that is longer on the left side. So this is going to be skewed left. Here I have data that is perfect, right? If I folded this side over to this side, it would match. And on this guy, I have a tail that's being pulled far out here to the right. So this is going to be skewed right. Right? A tail to the left is skewed left. If it's perfect, if it's beautiful, one side is equal to the other, that's called symmetric. That's kind of just a way we define beauty. If something is symmetrical, right? If someone is more pretty, they say if their face is symmetrical, if the left side is equal to the right side. And skewed right for the last one, if I have a tail going out to the right. Okay, so that's left, right, skew, and then symmetry. The last thing we want to talk about here, you can go ahead and pause the video, try this, but we also have mean and median, and I'll pick up and talk about this. So please pause the video and try these ones on your own. Alright, so these problems, here I have mean equal to median. That is going to produce a symmetrical curve. Here, notice my data is being pulled out here to the right. That's skewed right. Additionally, the mean is greater than the median. If my mean is on the right side of my middle, then it is skewed right. Here, my mean's on the left side of my median, so it is skewed left. And we have the longer left tail. The examples we're going to look at right now kind of deal with the mean and median concept. So please go ahead and write down these values in your notes. 86, 24, 65, 65, 24, and 24. And what we want to do is we want to calculate the mean and the median. So I'm going to go ahead, I'm going to add these guys up. So 24, oh I guess reorganize them. 24, 24, 24, we have 4 of those. 2 65s, 65, and 86. So here's my numbers. My median, that is my middle number. That's going to be right here in the middle. And if we go ahead and if we add all of these guys up, so I'm going to add in our calculators, so please use your calculators. 24 plus 24 plus 24 plus 65 plus 65 plus 86 is 288 divided by 6. It should give us 48. So our mean is 48. And if I want to average these two guys, 24 plus 65, that is going to give us 89 divided by 2. And 89 divided by 2 is 44.5. So 44.5. Okay, and that's what I have. So since my mean is greater than my median, the mean is on the right side of my median, I know this is skewed right. And here's our justification. This is skewed right because the mean is greater than the median. Okay, hopefully you can go ahead and write this problem down in your second example. And what I would start doing is I would start writing these in order. I have 3, I have 21, I have 22, I have 22, 25, and 26. Okay? And what I want to do is I want to go ahead, I want to find out, is it skewed right, left, or is it symmetric? And we do this by comparing the mean and the median. So to calculate the mean, I'm going to add all of these guys up. I'm going to add them all up. Well, we can do this without a calculator, but in order to save some time, I'm going to go ahead and do it without do it with a calculator. I'm going to add 3 plus 21 plus 22 plus 22 plus 25 plus 26, and that gives me 119. And when I divide this by the 6 values that I have, 1, 2, 3, 4, 5, 6, I get 19.83. So my mean is 19.83, and again, I got that from taking all of my values, 119, added them up, and I divided by 6. The median, that's the middle value. So since I have 6 numbers, I know I'm going to have to take the average of 2, and my middle 2 numbers are 22 and 22. Well, the average of 22 and 22 is just 22. Right? So therefore, since my mean is less than my median, since the mean is less than the median, this tells me that this is skewed left, because my mean is on the left side of my middle, and my tail is being pulled to the left. The reason for all of this, right, is because of this guy right here. This 3 is dragging everyone else down. This is saying the average is about 19, about 20, but all my values are bigger than 20, except for this guy. He's pulling everyone down. So the median in this case would be a better description of center, right? Tying in yesterday's lesson. Okay. I would like you guys to go ahead, please write down these values, write them in order. I want you to try this one on your own. Please pause the video right now and try this guy. Hopefully you've had a chance to try this problem, and you should have gotten 38 for your mean, 38 for your median, which is exactly equal. When I have this, this is a symmetric case. This data set is symmetric because the mean is equal to the median. Please try this last example in your notes. Please write this one down, pause the video, and try this guy. Okay, for this one, we have a mean of 27, a median of 23, and since our mean is greater than our median, our average is bigger than the middle, that's skewed right. The mean is on the right side of the median, right, if we're on a number line. So this data set is skewed right. Okay, we were able to accomplish our objective and describe shapes of graphs and data sets. And for our closure on the back, I would like you to just go ahead, sketch the following. Sketch what a symmetric distribution looks like, and sketch what a skewed left distribution looks like, and sketch what a skewed right distribution looks like. Hopefully, if you've done that by now, pause the video if you want to try it without peeking, but hopefully you came up with something like this, right? A perfectly symmetrical distribution. Kind of looks like the Snapchat ghost. Ooh. And then on this one, if it's skewed left, you have a tail going to the left. On this one, you have a tail that goes to the right. Okay, skewed left, skewed right, symmetric. Schwarberg, oh wait, before I do that, like my stuff, subscribe. Schwarberg is out. Peace.